All right. We have went through the two identity of a perfect square. All right, these two, okay, they are both examples of perfect squares. Huh? Okay. So now what about this guy over here? Okay, this is the last one. All right, the last identity that you will be learning. So again, when you expand this, what do you think will happen? All right, now let's work it out together. All right, I'll put some numbers here so that you can see what's going on first, and then I'm going to change it like this to a general expression. So again, let's work this out as usual. Okay, this one, if you notice what's the difference between what we have done so far, one of the bracket is positive and one of the bracket is negative, right? Let's see what's going to happen. So if I have this x, oopsie, just multiply in like so, I should get x squared minus 3x, right? And I will expand this again. I should get plus 3x minus 9, all right? Please remember, please be very, very careful about the sign. So when you simplify this, you should get x squared minus 9. Okay? Do you get that? Can you see what happened to these two terms over here? They cancel off each other. So which means I end up with this. Try to take a look. This one, and this one. This one and this one has three things. 1, 2, 3, right? But however, this one, oh, they have only two things, right? Interesting, right? So let's change this into a general expression and let's see what's going on over here. Okay? So let's change this again to a general expression. And let's see what's going on. Huh? So since I have the same number here, again, I'm going to put x, one of them is plus a, and one of them is minus a. Okay? So because we have done this, because we know that middle term will cancel, so what will happen? Try to look at this. How do we get this x squared? It's from these two multiplied together, right? And how do we get this minus 9? It's from these two multiplied together. Why is there no middle term? Because they cancel each other. So if you expand this like so, you should get x squared. All right, and then minus a squared. All right, remember it's always minus here. It's always minus here. It's always x squared minus a squared. Okay. Now what is this telling you here right now? I have x squared minus a squared. Again, what we're talking about, when we talk about power of 2, what is the object that we are dealing with right now? It's a square, right? So what is this expression telling me? It's I have a square and I subtract another square. It's like I have a bigger square and I take away a smaller square out of it. Make sense? So because of that, the name of this expression is literally called difference of square. That's the name of this expression. It's a very literal explanation. I have a square, right? And I take away another square. It's the difference of square. That's the name, all right? Now I'm going to show you the proof of this, okay? Now this is going to be very similar to this guy over here. Now straight away, I'm going to show this to you. Oops. I want to put this up straight away. Okay, all right. Now let's look what we are looking at. What we're looking at. All right. Again, I'm going to prove to you where are all these things over here. Now, if you notice over here, I have x minus a over here, right? We have dealt with this before, over here, right? So again, I'm going to draw this out directly. So we know that this whole thing, that's going to be x, right? And if I were to draw a line here, okay, so this one That's going to be A, correct? Okay? So, where's x minus A over here? Same thing, all right? Same thing. It's going to be here. Right? Okay, let's stop with that first. So at least you know what we are dealing at. Okay? Now, what I have shown you over here, right? I have my x minus A done. There it is. Okay? Now, I'm not going to go here first. I'm going to go here and here first. Again, where's my x squared? We have already established where's x squared in this diagram. That's going to be the whole thing, right? So if my x is over here, my x is over here as well. This whole blue square, that's x squared. Okay? Now where's my a? My a is over here, alright? Where else? Okay? We have already established where's a over here, so that's gonna be somewhere around here lah. Okay, I'm gonna make some space. So my a is gonna be somewhere over here. So if I want to draw a line, looks like this. Okay? So over here, if this is a, that's a as well. If this is a, that's a as well. So where's my a squared? This guy. Alright. So do you agree that x squared minus a squared is basically this whole square take away this guy? Alright. So what I did, I have just take away. I have just remove. Okay? I have just removed. So that's the difference of square. You see, I have a bigger square, subtract a smaller square. So that's the difference of square over here. Okay? So I've shown you where is this guy, where is this guy, where is this guy, right? Okay? Subtract means I take away, remove. But where's this guy? X plus a. Where's him? Right? So if you want to try, you can just pause the video a while and try to look for it. Alright? So while we are doing that, I'm going to show you where is it. Now this is a bit tricky. Again, we are in mathematics, and when we're dealing with mathematics, we dislike shapes that doesn't have a certain pattern. We want the shapes to be perfect, right? So what can I do over here to make things look much more organized? Okay? Now, see what I will do. I will do something very interesting here, okay? Because you look at this part, it's like some extra part. Why don't I just remove it? Okay, I want to remove this, but I will not throw it away. I will relocate this. Okay, instead of putting it here, I will relocate this to put here. Hey, take a look, take a look, take a look. What do I have now? Right, what do I have now? I have a rectangle. And we know what was this, right? I have already shown you that this is A. Alright? So if we move here, so we know that from here to here, that's A. Correct? So what is the expression for this whole length over here? That's going to be x plus A. Right? And what about this guy over here? Okay, we have already established this is x minus a, and it's a whole rectangle, so we know this whole thing over here, that's going to be x minus a. Can you see that? So this whole thing, alright, I'm going to erase a bit so that you're not confused. So this whole thing is going to be x plus a multiplied by x minus a, it's the difference of square. Can you see that? Alright, so this thing and this thing, it's the same, alright? But when I rearrange it, looks like this, we can find where is this from. Okay? Alright, so that's the proof. Alright, that's the proof of all these three identities over here. Okay? Two of these are perfect square, and this guy over here, that's the difference of square. Okay? And these are the three identities. It's going to be very important when we are expanding or when you are doing question that's related to factorizing. Okay?